Hello, good evening, students. So we are discussing the topic solutions. Okay, so here we are going to start with the MCQs. So last two classes also we have solved some questions. So we'll solve some more. Okay, so this is our first question. So the first question is, which of the following is dependent on temperature? Okay, A, molarity, B, mole fraction, C, weight percentage, D, molality. So this is a question came for NEET, for NEET exam 2017. So this is a question. So what is, so which of the following is dependent? Okay, which of the following is dependent on temperature? So A, option molarity, B, mole fraction, C, weight percentage. So we have solved similarly in the previous classes. Yes, can anyone tell? So what is, yes. Okay, so we'll see. So we'll see. Okay, for others, I'll just, yes. Yes, it is correct. Okay, so how it is molarity, we'll discuss. Just a second. So first option is molarity. So molarity is expressed as in capital M. So what is molarity? It is number of moles, right? Number of moles of solute divided by volume of solution in liters, right? In liters. So this is the molarity. This is molarity. Now, if temperature is changed, now what they have asked, so which of the following is dependent on temperature? Now, suppose if you have changed the temperature, okay, so what will happen to number of moles? Okay, number of moles, it is dependent on what you say, it is weight dependent. Okay, so this will not affect, but volume. So volume, if temperature is changed, what will happen if temperature is changed? If temperature is changed, then volume will increase or decrease. Okay, it will either increase or it will decrease. So, thus what will happen if temperature is changed, if volume is increase or decrease, what will happen to molarity? Molarity also will increase or decrease. Okay, it will increase or decrease. So this is our, so it is dependent on temperature. So molarity, it is dependent on temperature because volume, if you change the temperature, what will happen to volume? So volume will either increase or it will decrease. So if volume increases or decreases, so molarity also will increase or decrease. Okay, so this is our so it is dependent on temperature. Okay, so this is right. So we'll see the other options also. We'll see for B. Okay, what is B here? So B is mole fraction. So when you're talking about mole fraction, what is mole fraction? What is mole fraction? Mole fraction is number of moles, okay, of A, number of moles of A divided by the total moles of A and B, right? So this is, now how do you calculate the moles of A? Okay, for a particular component A, how do you calculate? So it is given weight divided by the molecular weight, right? This is how do you calculate the for particular component A. If you are calculating for a particular component A, then how it will be given weight divided by the molecular weight. Now, when you're talking about number of moles, okay, number of moles means what? Given weight upon molecular weight. It comes on weight. Now, if weight is what? Weight is dependent. Okay, weight is dependent. So when temperature, so if temperature increases, it will not, it does affect the molecular weight. So what will happen? There will be no change in the temperature. So this is not dependent. So this is not dependent. Okay. So B option is striked out. Now we'll see the C option. C option is what? Weight percentage. Now weight percentage. Okay, weight percentage. Now, when you're talking about weight percentage also a dependent quantity, right? Weight percentage is a dependent quantity, right? Weight component is also percentage is also a dependent quantity. Now, what will it will happen? So it will so when there will be increase or decrease, so it does not affect. So it will not affect. So temperature also will. So what will happen? Temperature, if you increase or decrease the temperature, okay, so it will not affect. So temperature does not affect in case of weight percentage also. Then option D. So this is also striked out. Now we'll see the next option, that is D. D. D is what? Molality. So molality, how is molality expressed? Molality is what? Number of moles of solute, okay, divided by weight of solvent, right? Weight of solvent. So here again, weight is dependent, right? Weight is dependent. So weight is what? Weight is dependent. So what will happen? So thus here also temperature, so weight is dependent, so temperature will not affect. So here also temperature does not affect. So this is also striked out. So what it is? Molality. So our correct option is what? A. A is the correct answer. Why? Because molarity is nothing but number of moles of solute. You know how to calculate the number of moles of solute. That is given weight upon molecular weight. So weight is dependent, so that is striked out. But volume, when you're talking about volume, so volume of solution, so if you increase the temperature, volume will also increase or decrease. So if there is change in the temperature, volume will either increase or it will decrease. So thus molarity also will increase or decrease. Okay, so our option A is the right answer. Yes. Okay, so here Shweta and Satyapriya has answered it right. Okay, try to answer the MCQs, because we have already discussed MCQs in last two classes. We have been solving it. So now you have to also try. Okay. So next question. What is the mole fraction of the solute in a 1 molar aqueous solution? Yes. Try solve this. Try to solve this. Try to solve this. What is the mole fraction of the solute in a 1 molar aqueous solution? Yes. So how to solve this? What do you mean by 1 molar? Molar. What do you mean by 1 molar? What do you mean by 1 molar? 1 molality. 1 molar is nothing but molality. Molality. How do you express molality? How do you express molality? Molality is what? Molality is what? Number of moles of solute divided by, yes, can anyone tell me what is molality? Molal. Molal is nothing but molality. How do you express molality? 1 molality, number of moles of solute divided by
1000 gram.
Yes, that is you are taking the weight of the solvent in kg. Okay, so that is the weight of the solvent. You are taking the volume of solvent in kg. So it is kg of solvent. The solvent taking is in kg. Okay, so this is the molar mass. Now, what is they have asked? What is the mole fraction of the solute in 1 molar aqueous solution? Okay, so this is molality. Now, what is the molar mass? Molar mass of water. Aqueous solution means what? Water. Okay. Now, what is the molar mass of water? Water is what? Hydrogen is 1 into 2 plus oxygen is 16. So it is what? It is 18. So 18 grams. Okay. So molar mass of water is 18 gram. Now 1 kg of water. Okay, 1 kg of water now, okay, so molar mass we have discussed. Now, what is this 1 kg? 1 kg is which 1 kg? This. Okay, 1 kg of water means what? 1 kg of water means 1000. Okay, 1000 grams per mole. Okay, 1 kg is what? 1000 grams. 1000 gram per mole divided by 1 kg is given weight. So it is 1000 kg that is 1000 gram per mole divided by molecular weight, right? So molecular weight is what? It is 18 gram, right? So this is, so when you calculate this, it comes to, that is 1000 divided by 18, it comes to 55.56. Okay, it comes to 55.56 mole. Okay, now we have to calculate the total mole. How do you calculate the total mole? Total mole is equals to 1. Okay, 1 plus 55.56. So that will be 56.56 moles. Okay, so this is the total moles, right? This is the total mole. Now, mole fraction. How do you calculate the mole fraction? How do you calculate the mole fraction? Mole fraction is equals to, okay, mole fraction, just a second. Mole fraction is equals to, that is Na divided by Na plus Nb. Now, total mole fraction is what? It is 56. Now, what is mole fraction? 1. So, the 1 is, right. So, 1 divided by the total mole is what? 56.56. So, if you divide 1 by 56.56, it comes to 0.018. Okay. So, this is 0.018, right? So 0.018 means it is nearer to what? 0.018 is nearer to C option. So C is the right answer. So what is molality? So first you have to calculate the molality. So molality is what? Molality is number of moles of solute divided by the kg of solvent. Now you know molecular mass of water is what? 18 grams. So you know how to calculate this. Okay, total that is number of moles. Number of moles is calculated how? It is by 1 kg of water is nothing but 1000 gram. Given weight is what? Kg means 1000 gram. 1000 gram per mole divided by the molecular weight is 18. So it comes to 55.56 mole. Now when you are calculating the total mole, okay, so the mole fraction of a solute in 1 point molar aqueous solution is, so the total moles is 1 plus 55.56 is equals to 56.56 moles. Now mole fraction, how do you calculate mole fraction? Na divided by Na plus Nb. So Na plus Nb, you have already have this. So you just substitute this, you get, so 0.018. So C is the right answer. Understood? Yes.
Yes, ma'am.
Yes, Komal, your answer is right. Okay, it is C. So C is the, so try to solve this. Okay, and I hope you are copying the question. Okay, so this is the way you are going to solve this particular question. I'll go for the next. Okay. So we'll go for the next question. I hope you are writing down the solutions. Okay. So like this only, other, so same what type, okay, the type will be same, but the, what you can say, the only the change in this numericals, okay, only the numbers will be varying. So such type of questions are asked. So the next question is, how many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar HNO3? The concentrated acid is 70% HNO3. Okay. So how many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar HNO3? So where the concentrated acid is 70% HNO3. So what is the molarity given?
2.0.
Is given, yes. So molarity of HNO3 here it is given is 2 molar. Okay. So the HNO3, whatever is the given quantity, that, so first rule is what? Whatever is the given quantity in the problem, that you have to write down. So given quantity, first you have to write down. So what is molarity of HNO3? It is 2 molar. Now number of moles, next is number of moles of HNO3. So right, how to calculate the number of moles of HNO3? Number of moles, how do you calculate molarity? Molarity is nothing but number of moles, right, divided of solute divided by the volume of solution, right? So I'll just write it here. You know this molarity. Number of moles of solute divided by volume of solution, right? So now we are finding the number of, so molarity is given, right? Volume is also given. So now, so first will, so number of moles of, if you just cross multiply it, so number of moles of solute can be written as what? Is equal to molarity into volume, right? Molarity into volume. So volume you have to convert in liters, right? Volume you have to convert in liters. So just a second, I'll write it down here. So here, so next step is what? Now we have to convert our this. Okay, your ml 250 ml they have given volume, right? Volume is given in what? Ml. So that you have to convert it into, that you have to convert it into liters. Okay, so how do you convert it into liters? Now molarity is what? Molarity is 2, then volume is given as what? 250. So if you want to convert it into liters, okay, that is ml into liter, divided it by 1000. Okay, divided it by 1000. So after solving this, what you get? Okay, you get 0.5. So this is the number of moles of HNO3. It is what? It is 0.5. Okay, it is 0.5. Okay, it is 0.5. Then, so next step is what? You have to calculate the, what they have asked, how many grams of concentrated nitric acid solution should be used. So we have found out the number of moles. Now our next step is what? You have to find out the how many mass. You have to find out the mass of HNO3 which is required, okay, to prepare this much of solution. So next step is mass of HNO3. Okay, mass of HNO3 required. So mass of HNO3 required is what? Molarity. So that is 0.5 into the this what it is? Molecular weight. Molecular weight of HNO3 is what? Hydrogen is 1. Okay, then nitrogen is 14. Then your oxygen is 3 into sorry, this is plus. Okay, this is plus, then 3 into 16, right? This is the molecular weight. This is a molecular weight. So mass of the HNO3 required, you have to multiply it by the, you have to multiply your number of moles into the this molecular weight. Okay. So how do you get this mass of HNO3 required? So 0.5 into 63. So 0.5 into 63 is nothing but, see what you'll get, it is 31.5 grams. Okay, so this is the mass of HNO3 required. So see here, always number of moles is what? Number of moles is given weight, right? Given weight upon molecular weight, right? So this is the formula. Now what we want to find? We want to find the given weight. How much weight is required, that is how much mass is required to get so much of moles. Now we know what is number of moles, we know the molecular weight. So what we have done, we are finding molecular weight. So that is given weight. Given weight is equals to number of moles into molecular weight. So this, by this you get 31.5 grams. So this much 34. So for to prepare the solution of 2 molar HNO3, okay, so the number of, that is a mass of grams required, the constant, it is 31.5 grams. Okay, how much it is? It is 31.5 grams. So for the solution to prepare, it is 31.5 grams. Now the concentrated HNO3 given is how much? It is 70%. So the concentrated HNO3 given is 70%. So next step is what? Concentrated HNO3 solution. Okay, given is what? It is 70% HNO3. It is 70% HNO3. Okay, it is 70% HNO3. 70% HNO3 means what? 70% HNO3 means what? 70% means 70 grams of 70 grams of HNO3 dissolved in 100 grams of solution. 100 grams of solution. So 70, that is 70 grams of HNO3 in 100 grams of solution. Okay. So now what you have to do? So this is 70% this. So now they have asked, so how much grams of HNO3 is required? Okay, that is in 35 point. So that is, so next step is what? So for this much solution to prepare, okay, it is 70 grams HNO3 is required in 100 gram of solution. So for 35.31, how much we got? 31.5 grams of HNO3, how much gram of solution this is required? So just cross multiply. So you get what? Concentration solution is equals to 100 divided by 70 into 31.5 grams. That is equals to how much? It comes to 45 grams. So it is option C. Okay, option C. Understood? Just go through stepwise. If you did not understand any step, you can ask me. Yes. So what is given quantity? So what all are given? You can just see here. I'll explain it once more. So what is given in the question? So molarity is given. So molarity of HNO3 is what? 2 molar. Now, okay. So next step is what? We have to find out number of moles of HNO3. Now to calculate, you know what is molarity. Molarity is what? Number of moles of solute divided by volume of solution. Now here volume of solution is also given. It is in ml. So you know what? You know the molarity, you know the volume of solution. So to find out the number of moles of solute, what you have to do? You have to multiply molarity into volume of solution. So that we have done here. Okay, that we have done here. Volume into this molarity. Okay, capital M. Now, molarity is what? It is 2. Volume, if you, so volume is given in ml, that we have to convert it into liters. So whenever you're converting ml into liters, it will be 250 divided by 1000. You have to multiply it by, sorry, you have to divide it by 1000. So 2 into 250 divided by 1000. you get 0.5. So that is number of moles of HNO3. So this is the number of moles of HNO3, that is 0.5. Next step is what? They have asked us what? They have asked us mass of HNO3 required. Okay, how many grams of HNO3 is required? Now, number of moles. Okay, number of moles is what? Number of moles is given weight upon molecular weight. If we don't know what is given weight, we know what is number of moles and we know the molecular weight. Now, what we will do? So, mass of the HNO3 required is equal to, so just multiply number of moles into molecular weight. So, number of moles is what? 0.5. What is the molecular weight? Molecular weight of HNO3, hydrogen is 1, nitrogen is 14. Then how many oxygen atoms? 3 oxygen atoms. Each oxygen atom is 16. So this total, if you do, it will comes to 63. So molecular weight will be 63. So 0.5 into 63, it comes to 31.5 grams. So 31.5 grams of this HNO3 is required to prepare 2 molar HNO3, okay, of 250 ml. Now the concentration of HNO3 given is 70%. Okay, so we have to take with respect to 70% HNO3. So concentration of HNO3 solution is 70% HNO3. So 70% means what? 70 grams of HNO3 is dissolved in 100 grams of solution. So for 31.5 grams, okay, how much is it? You have to just, what is the concentration? So you have to just cross multiply. So it will be 100 divided by, okay, 100 multiplied by this, what you have to just cross multiply. So 100 into 70, 31.5 divided by 70. So this comes to 45 grams. So it, C is our answer. Understood? So this is the way you are going to solve it. So we'll go for the next one. I hope you have understood. Okay, if you have any doubts, you can ask me. Yes. Okay, so we'll go for the next question. Which of the following compounds can be used as antifreeze in automobile radiators? Okay, antifreeze. So, so here, so options are A, methyl alcohol, B, glycol, C, nitrophenol, D, ethyl alcohol. So, what do you mean by nitro-freeze? Okay, so which of the following compounds can be used as antifreeze in automobile radiators? Okay, so here glycol. What do you mean by glycol? So the answer is B. So why it is B? That is ethylene glycol. Okay, ethylene glycol. How is the ethylene glycol structure? It is CH2, CH2, OH, OH. Okay, so it is called as dihydric alcohol. So it is called as what? Dihydric alcohol. So it is, the name given is dihydric alcohol. So this is used as antifreeze. Why it is used as antifreeze? Because they have lower freezing point. Okay, they have lower freezing point than water. Okay, and what they do, they prevent in bursting of radiators. So it is used in automobile radiators. So thus they prevent the bursting of radiators. Okay, and when you're talking about specific heat, so specific heat of antifreeze is lower than that of the pure water. So thus glycol, okay, ethylene glycol is used as antifreeze in automobile radiators. So option B. Okay, option B is the correct answer. Okay, what is the reason? So antifreeze, why antifreeze is used? Because they have lower freezing point than that of water. This is the first point. Second point is what? They prevent in bursting of the radiators. Okay, and the third point is what? The specific heat of an antifreeze is lower than that of pure water. So these are the reason, and so thus glycol is used as an antifreeze in automobile radiators. Okay, so next question. Concentrated aqueous sulfuric acid is 98% H2SO4 by mass and has a density of 1.80 gram, okay, ml per ml. volume of acid required to make 1 liter of 0.1 molar H2SO4 H2SO4 solution is. Okay, so these are the options. So here, what is given here? So here, molarity. Okay, so it is, the problem is of molarity. So molarity, you know, the given equation for molarity is M1V1 is equals to M2V2. So this equation, by using this equation, we are going to solve this particular question. Now, what are the given quantities? Now, what are the given quantities? We have to write. Now, M1 is what? M1 will be your given initial. Okay, M1 will be a given initial molarity. So, given initial molarity is your M1. Then, what is M2? M2 will be your final, or it is required molarity. Okay, it is required molarity. So it is required molarity. So it is required molarity. Then what is V1? So V1 is not given here. You can see V1 is not given. Then V2 is what? V2 is what? V2 is 1 liter. Okay. V2 is 1 liter. So we'll write 1 liter. Now, here what all is given? So we have given. So M1 is the initial molarity. What is the initial molarity? Initial molarity concentrated aqueous solution M1. So that also we don't know. So M1 we don't know. Okay, M1 we don't know here. Then volume of acid required to make 1 liter of 0. So M2 is what? 0.1 molar. So we know M2, we know V2. We don't know M1, we don't know V1. So now this is given, right? 98% H2SO4 by mass. What do you mean by 98% H2SO4 by mass? So 98%, okay, of H2SO4 by mass means what? It is 98 grams of H2SO4 in 100 grams of solution, right? So this is the 98% of H2SO4 by mass it means. So what is your mass? So mass is what? Mass is 100, right? Mass is 100 grams now. And here what is given? Density is given. What is density? Density is 1.80 gram per ml per ml. Okay. So this is density given. Now, if we know mass and density, can we find out volume? What is volume? Volume is nothing but mass and density. So volume of solution is nothing but mass upon density. What is mass? Mass is 100. Density is what? 1.80. So just solve. What you will get? Yes, what you will get?
55.5.
Yes, you will get 55.5. So it will be 50.555 ml. Okay. So it is in terms of ml. So 55.55 ml. So from this we have got what? We have got our V1. Okay. We have got V1 now. Now next step we have to find M1 now. M1 is what? M1 is, so this is volume of solution. So we have got the volume of solution. Next step, we are finding out M1. So molarity is what? Molarity is number of moles of solute, divided by volume of solution in liter. Okay, volume of solution in liter. So now we will, whatever is the given entity, we will write down. Now, number of moles of solute is what? It is 98, right? Number of mole, 98 grams of solute. So it is 98 grams. Okay, divided by this what? The number of moles means what? Given weight upon the molecular weight. So given weight is 98. 98 divided by what is the molecular weight of H2SO4? H2SO4 molecular weight, calculate 2 into 1 plus sulfur. Yes, what is sulfur? What is the atomic weight of sulfur?
32.
32. Plus, then what? Oxygen, 4 into 16. How much it comes to? Yes, how much it comes to?
200.
It is coming to 200. Huh? 2 plus 32 plus 16 into 4. No, it will come to 98. 2 into 1 plus 30.
Yes, ma'am.
Yes,
98.
yes, it is 98. So the molecular weight of H2SO4 is also 98. So how do we are substituting this? Number of moles of solute is nothing but given weight divided by molecular weight. Okay. So we are writing that given weight, we know it is 98. And what is molecular weight is also 98. Now into what is the volume? Volume is 55, right? Volume is 55. Just a second. 55. So it is 55.55. Okay. Into, so it is in ml. Ml means you have to divide it by 100,000. So divided by 1,000. So I'll just see here. Actually, it is like this. Wait, I'll show you. Given weight by molecular weight. Okay. Now, number of moles of solute. Given weight is what? 98. What is molecular weight is also 98. Okay, this is our solute. Now, when you're talking about volume of solution in liter, what is this volume? It is 55.55. Now, this is in ml. ml means you have to multiply it by, divide it by 1,000. So, this is our, so what will happen? So, I'm just rewriting it as 98. Now, 98 and this 1,000 will come here. So, it will become 1,000. Then again 98 into, this is in denominator, so it will become 55.55. Understood? So I've just simplified it. Now just tell what will be the answer. What will be the answer? 98 into 1,000. Then see, first do it stepwise. 98 into 1,000. Then divide it. Then again down part denominator you do 98 into 55.55. Then whatever the values you get, then you divide it. Go stepwise. If you do stepwise, then you will get proper answer. Yes. $98 into 1,000 is 98,000. Then 98 into 55.55. This comes to 5443.9. Now you do 98,000 divided by 5443.9. So it comes to
180.
18.02 gram per mole. Okay, sorry, gram per mole. No, it will be this will be what? 18.02 mole per liter. Okay, it will be mole per liter because this is in terms of moles, number of moles. This is mole, and this is in terms of liter. So mole per liter. So it is 18.02 mole per liter. Now, so now you have to, whatever the given this is there. Okay, you have to put all the given data in M1 V1 is equals to M2 V2. So in this particular formula, you have to put. Now, what is M1? M1 is 18.02. So we have got this M1, right? This is M1 is 18.02. What is V1? V1 we don't know. Now, what is M2? M2 is what? M2 is 0.1. See here, M2. M2 is 0.1. And what is volume? Volume of this is 1 liter. 1 liter means again you have to do what? You have to do 1,000. Just So 0.1 into 1000, right? Then, so this is your what? In your particular formula. Now V1 you keep aside, so it will be 0.1 into 1000 divided by 18.02. Just see what you are getting answer. So 0.1 into 1000. So it comes to
Option C, ma'am.
100. Then divided by 18.02. Okay, divided by 18.02. Now 100 divided by 18.02. So it comes to 5.54. So it is nearer to 5.55. So our answer is C. Understood? Yes, so answer is C. I hope you are understanding the questions. Yes. Any confusion you can ask me. Is it clear? Okay. Others, only one person is answering. Others, understood? Okay, fine. So we'll go for the next question. So the mole fraction. So the mole fraction of the solute in 1 molar aqueous solution is, okay. So sixth one molar solution means what? 1 molar solution. 1 molar solution. 1 molar solution is what? Molality. Molality is what? Number of moles of solute divided by solvent, that is weight of the solvent in kg, right? So weight of the 1 molar solution, you have to consider the weight of solvent in what? It is in 1 kg. Now mole, what they have asked, mole fraction of solute. So how do you calculate mole fraction? So mole fraction is equals to that is moles, number of moles of component 1, right? Component 1 divided by the total moles, right? Total moles of A and B. Now, what is number of moles? So here 1 kg. So it is for 1 kg. So it is 1 divided by, okay, 1 divided by 1 plus. So this is for component A and B. So mole fractions here. I'll write again. Mole fraction is what? Mole fraction is equals to Na plus Nb. Now, 1 is Na. Okay, 1 is Na. So 1 plus. Now, this what is that? Weight of solvent is in kg. So kg means you have to write it what? Given weight upon molecular weight. Given weight is what? 1000. What is the molecular weight is 18, right? So this do now. How you'll get? What you'll get now? So 1 divided by 1 plus 1000 by 18. See what you're getting?
$56.5.
See, first you do 1000 divided by 18. Yes, you get what? 1 divided by 1 plus 55.55. Now 1 plus 56.55. Now 1 divided by 56.55.
0.076.
76. So 0.0176 is nearer to which value among the four? So option B is the correct answer. So the mole fraction of the solute in 1 molar aqueous solution. 1 molar means what? Molality. So molality is nothing but number of moles of solute divided by weight of the solvent in kg. So mole fraction is what? Na, that is a mole of the number of moles of component A divided by number of total moles of component A and B. So this is what 1. So number of moles of component A is 1. Then 1 plus then weight of the solvent. Weight of the solvent is in kg. Okay, so given weight is what? 1000. So 1000 divided by the molecular weight is 18. So just substitute the given this, and you will get what? 0.0176. So it is nearer to 0.0. So 6 is nothing but it comes add up. So it becomes 8. So this is 0.018. So our answer is B. Okay. So we'll solve one more question and then we can stop. So 2.5 liters. Okay, 2.5 liters of 1 molar NaOH solution is mixed with another 3 liter of 0.5 molar NaOH solution. Then find out the molarity of resultant solution. So here two types of NaOH solutions are given, right? So here two types of NaOH solutions are given. So this is one type, right? And this is another type. So there are two types of solution is given. So this is one type and this is another type. So these are the two types of NaOH solution. So one type of, so once this concentration is what? It is 1. Okay, one solution's concentration is 1 molar and another solution concentration is 0.5 molar. So we'll write the given quantities. So initially, what all is given? So M1 is what? So M1 is 1 molar. Okay, so this is 1 molar. So what is the volume of that? It is 2.5 liters. So V1 is equals to 2.5 liters. Okay, it is 2.5 liters. Then M2, is equals to the another solution. It is 0.45 molar. Okay, then what is volume? Volume is 3 liters. Okay, it is 3 liters. Now, what we have to do? We have to find out the resultant molarity. Okay, so it will be V1 plus V2 is equals to V1 plus V2 is equals to what? 2.5 plus 3 liters. Okay, so it will come to what? It will be 5.5, right? So now we'll find the resultant molarity. We'll find out the resultant molarity. It will be M1 V1 plus M2 V2 divided by M1 V1. Divided by V1 plus V2. So this is our formula. So to find out the resultant, whenever two type of this is given, two types of solution is given. So whenever two types of solutions are given, okay, so you have to find out the resultant. It is how M1 V1 plus M2 V2 by V1 plus V2. Now write down the quantities. M1 is what? 1. Then V1 is what? V1 is 2.5. Then plus V2, M2 is what? 0.5. Plus V2 is into V2 is what? V2 is 3. Then divided by what is the total volume? V1 plus V2 is 5.5. See, check what will be the total resultant molarity. What is the resultant molarity? What is the resultant molarity? Yes. It is 0.727. Yes, 0.727. It is approx 0.73. Okay, so our answer is C. C is the answer. Okay. I hope you have understood. Right. So here two types of NaOH concentration solutions are given. Right. So we have to use the resultant whenever two solutions are given, you have to find the molarity of the resultant solution by using this particular formula, right? So whatever the given entities are there, just add it in the formula and you will get the answer. Okay. So remaining questions we can see in the next class. So I'll stop the class here. So we'll continue it in the next class. Thank you.